Alright, limit properties. I'll make this video as quick as I can. So the limit properties are scalar, sum, product, quotient, and power. We're also going to look at one more called composite. So the scalar multiple property says that if I know the limit value of a function at a certain point, I also know the limit value of any scalar multiple of that function at that point. And so if I take the limit of x squared as x goes to 5, that should give me 25. And then if I take that and I multiply my x squared by, let's say, 1/5, so I have a new limit, or a new function taking the limit value of, then I can also just divide 25 by 1/5, or by 5, and I get my new limit is 5. So if I multiply the function, I can multiply the answer and still get the new answer. Alright, sum or difference property. If I know the limit values of two different functions at the same index value, then I can find the sum or difference limit value as well. So let's take two different limit values here, or limit functions here. Limit as x goes to 3 of x squared, which is going to be 9. And then I can also take the limit as x goes to 3 of 2x minus 1, and this will give me 5. So I can now find the limit of, as x goes to 3, of x squared plus 2x minus 1, and this will be equal to 9 plus 5, which is 14. Ta-da! Real simple and easy. Alright, product principle. If I know the limit value of two functions at a certain index value, then I also know the limit value of these two functions when they are multiplied together. So this will be a difference of two squares. Take the limit as x goes to -1 of x minus 3, and this will give me a -4. And for my second function, I'm going to do the limit as x goes to -1 of x plus 3, and this goes to a limit value of 2. So if I take these two and multiply them together, I get a function x squared minus 9, which is just these two functions multiplied together, and the limit will be -4 times +2, which gives me a new limit value of -8. Notice that each of these so far have to have the same index, which for this exact example is -1. Quotient property. If I know the limit values of two functions at a certain index, then I also know the limit value of the quotient of these two functions. So for my first function, I'm going to use x squared plus x minus 6. Plus 6. Plus 6. Which gives me a limit value of 6. And I will also use the limit as x goes to 0 of x plus 3. And this will give me 3. So if I do the quotient of these two functions, so as x goes to 0 of x squared plus 6, or plus x plus 6, divided by x plus 3, then my new limit value should be 6 divided by 3, which is 2. And you can try it out and you'll find out that it actually is. Alright, power. If I know the limit value of a function at a certain index, then I also know the limit value of the function if I choose to raise the function to an exponential power. So if I take a simple function like the limit as x goes to 5 of x plus 2, then this will give me a total of 7, or a limit value of 7. And then I raise that function to the power of, let's say, 2, so I square it. Then my new limit value should be the same as my original limit value squared. So I should end up with a total of 49. All right, the composite function limit. If I know the limit value of g of x and the function value of f of x at some index, okay, not necessarily the same index, then I also know the limit value of f of g of x. So using my function value, my f of x is x squared plus 4, and my g of x is going to be the square root of x. Notice that I am not using the same index here. I'm using two different indices. So the limit as x goes to 0 of the square root of x squared plus 4 is going to be equal to 2. Alright, so notice I did not use the same index the entire time. I had to use the answer from the blue equation as the index for the red equation in order for this to work. Alright, that's it. Review if you need to, and see you tomorrow.